Alright, hello. Going to do a short video here to try to work out some of the practical details of pointers in C. So I have some test code that I've started to put together. So basic main program in C, I've got three integers A, B, C, and I have a integer star pointer. And a lot of times you see these things written as integer star space PTR, which I think I was saying pointer is a variable. What type of variable is it? It's an integer star, right? It's a type of variable which points to an integer. But sometimes it's written like this and it looks like star pointer. Spaces don't really matter in this case, but if it helps to think of it as star being part of the int, that's fine. Alright, so we're just going to print out the initial value of pointer before we do anything with it. We're going to print out the values of A, B, and C, which should be 10, 20, and 30. So let's go ahead and run this. And A, B, and C are 30, that's not a big surprise, but pointer is equal to nil, which is an important thing to note because this is really just a declaration of a type of variable. We're saying pointer is going to be a reference to an integer, but we have not given PTR pointer a value yet. Just like if we say integer A semicolon, we don't necessarily know what the value of A is. Now if we define the value with an assignment statement, then A, B, and C have good values, but pointer hasn't been assigned yet. So if we try to use pointer, we're going to get a segfault. So let's just see that. Let's just say pointer points to, and let's print out the value of star PTR. And when we do that, we get our segmentation fault because pointer is not pointing to a valid memory location. So segfaults almost always are telling you that you've got an uninitialized pointer somewhere. Not always, but that's sort of your first go-to if you find a segfault. Okay, so before we print out the value of pointer, the thing that it points to, let's give it a value. Let's say pointer equals ampersand A. And what is that doing? Well, ampersand A is the address of variable A. Where is A stored in memory? It's some weird, big, long hexadecimal number. And so if we set pointer equal to that and we say star pointer, we should just find that A is pointing to, or pointer is pointing to A. Right? A is equal to 10, and that's the value of pointer. And it's a little strange that pointer has a value that's not nil now. That's totally a random artifact, okay? But let's see what the value of pointer is once we set it equal to the address of A. So let's print out the pointer itself with a %p. And you find that pointer is equal to this weird number, which is kind of close to this original number that it had, but this original number is just kind of random, right? And it's not the same from run to run either. But this value of pointer right here, that's the address of A, and that's what pointer is pointing to now is A. So here's a comment, since pointer points to A, we can change A by using the thing that pointer points to. So if we set star pointer equal to 42, and then print out what pointer points to, and print out the values of our variables. Alright, so here's the original values of our variables. Here's the original value of pointer after we set it equal to the address of A. It says pointer points to 10. Now we changed star pointer to be 42, and it said now pointer points to 42. That's not surprising. What may be a little surprising or delightful is that A is now equal to 42. We didn't change the value of A in here, but we did change the value of star pointer. And since pointer was supposed to be the address of variable A, when we say find what pointer is pointing to and set that to 42, well, pointer is pointing to A, so this effectively says change A to 42, and now when we print the value of A, A is then changed to 42. Okay, so that's the first aspect of pointers. Let's come back and see how we can do this with characters, and this is going to let us do some pointer arithmetic. So we'll come back in a moment.